We have a young celebrity guest. She's 17 years old. She's going to address on emergence of data as a business, its ethical use, and its opportunities for the decade ahead. I take the pleasure in introducing Ms. Ria Cheruvu, Intel Corporation Networking and Edge Group, IoT Group, and she works with the CTO's office in US. Ria is the AI ethics lead architect at the Intel Network and Edge Engineering Group, where she leads a team responsible for productization of AI ethics and explainable AI technologies. She is an emerging speaker in the industry and delivered technical talks for TEDx, IoT Village, and in data science communities. Ria has a master's degree in data science from Harvard University and served as an ambassador for the Harvard Kennedy School of Government's Future Society Initiative on AI ethics policy and governance, the rise of AI. It's such a privilege to have you with us today. Over to you, Ria.
Hi, I'm Ria, and today I'm going to be talking about ethical AI and data use, opportunities for the decade ahead. Let's get started.
20 minutes is almost close to 8.
In this keynote, I'm going to be going through a couple of interesting insights around foundational vectors of AI ethics. We'll also talk about a subset of connections to global policies that are important to think about as we start to understand and analyze the impact of AI systems and the implications. Finally, we'll conclude with a very brief AI supply chain analysis, including a description of some of the expected stakeholders for AI systems, and conclude with an innovative technological solution overview at software and hardware levels, followed by our conclusion and key takeaways. So let's get there. Let's first get into foundational vectors of AI ethics. So here, I'd like to bring to this audience's mind a interesting definition of AI ethics that is attempting to be comprehensive, but nevertheless can be generic and can be considered in many different lights. So here, the definition I'd like to propose is the following. AI ethics can be viewed as a socio-technical lens on the design and impact of AI solutions on our societies. Now, from my domain of expertise, I look at this in the form of Internet of Things use cases and ecosystems, where in this particular type of application, Internet of Things devices are considered to be consumers and producers of data, and also similarly enablers of actions made by intelligent autonomous agents, in other words, AI algorithms. Now, the insights for AI ethics apply beyond Internet of Things use cases and applications, but a lot of the interesting and new technologies as well as issues that are being raised for Internet of Things security and trustworthiness reflect very closely and are intertwined with the related issues for AI as well. But given that, let's take a step back now and think about the overall AI picture, not just influenced by edge devices in the cloud. What do we really mean when we say AI trustworthiness versus AI ethics? A lot of different definitions out there. What I'd like to propose here for the distinction between these two primary terms in the space, AI trustworthiness is really targeted around alignment, where the system itself has some mechanisms in place where it's able to establish and maintain the level of user trust that is expected. Now with ethics, again, we're really bringing in that societal impact point of view here. And I would like to phrase this as intention, the intention of the developers behind the system, the intention of the providers of the services, and the intention of the consumers of the system, all getting factored into the design and deployment of AI systems. Some of the issues surrounding this, as well as the mitigations, etc., can fall under the AI ethics umbrella. So given this, let's take a step further and do a deep dive into AI ethics vectors. Again, in this case, we're really having that IoT flavor here, but this is applicable for holistic use cases of AI, not restricted to the Internet of Things ecosystem. Again, here, what I'd like to propose are four primary vectors of AI ethics that are foundational for getting a grasp of the space and understanding the implications for business. The first is targeted around transparency. This can include concepts such as auditability and accountability. I like to boil this down to the right to understand the how and why behind AI decision making throughout development and deployment. Next, we'll turn to a very interesting concept that is now being introduced as part of AI ethics and also relevant for semiconductor professionals to be aware of. This new vector on energy efficiency and sustainability of AI solutions as being critical to potentially enhance the trust of an AI system. And here I'm citing a statistic from the Stanford High blog post stating that training an off-the-shelf AI language processing system reportedly produced approximately 1,400 pounds of emissions, about the amount produced by flying one person round trip between New York and San Francisco. It's an alarming statistic. Now, there's a couple of debates in the field around how this really applies to training and deployment, and whether or not it really is a big deal or not. What we're starting to see, though, emerge out of all of these debates is that low resource implementation of AI algorithms and IoT ecosystems can be seen as an imperative and will be phrased as such going forward. So it's something for us to start thinking about and pursuing when it comes to building better trust and ethical intention into AI systems. Next, I want to talk about fairness and bias. This is really at the core of AI ethics, where we are considering from both the social context perspective around mitigating and preventing data sets and methodologies allowing AI to reflect manipulative power dynamics and oppressing particular target populations, in addition to the technical context, where we can really phrase some of these fairness-related concerns from the societal perspective as technical measurements. For example, representative allocation of resources and prioritization to particular edge devices in an Internet of Things ecosystem can be considered as a type of bias we might want to have. Now, I do want to note the blend between these two different types of context for fairness is not very clear. We cannot continue to have a technological solution for every societal fairness concern that is raised, which is why we need to be very clear on the types of regulatory guidelines and processes that we implement to address these two different types of contexts in their own right. Next, we turn to the security, safety, and privacy component, which is a critical facet of AI trustworthiness and therefore AI ethics as well. This can include ethical review and enforcement of end-to-end AI safety and privacy in the cloud, including sandboxes for isolation and model capabilities for testing purposes. Finally, I have this fifth domain here on vulnerable target populations and varying use cases. This really isn't a separate vector, but is influenced by all four of the above vectors in a multitude of ways. Where really what we are trying to understand and design for here is customizability of AI pipelines to accommodate regulatory and user feedback and social norms. Now, although this was a deep dive, it's still pretty high level on these individual points. So during this keynote, I'm going to be narrowing down on a couple of areas that we would want to talk about here, and then go into some detail there and leave some space for exploration and for further reading. So let's kind of now start to get into the standards related information and similar. So I wanted to provide an overview of trustworthiness in artificial intelligence based off of the ISO IEC standards that are work in progress, some of which have been published and some of which are still in formation. So here, the trustworthiness definition that's proposed is the ability to meet stakeholders' expectations in a verifiable way. The emphasis being placed on verification of meeting expectations. The notes here that are accompanying this definition are also, I think, important to think about, including mentions or links back to reliability, security, privacy, integrity, accountability, transparency, etc. So really, if we're starting to consider trustworthiness as this attribute being applied across the stack, and for business transformation and similar, there are a bunch of these additional attributes that we would need to think about when designing and again deploying AI systems. So now let's get into this a bit further. I want to introduce here those individual elements that we were talking about and tease them out a bit further in terms of the transfer of ethical and trustworthiness elements to AI pipelines and how this is critical. I've been emphasizing a lot so far on development and deployment. And what I really would like to emphasize on here is a lot of times, typically, these concerns are usually thought about during the design of the AI system. We need to get the right data sets. We need to make sure that the model being developed, has, a diverse set of developers who are able to understand the implications of the system and accommodate that, and also provide their views on the system. But during deployment, we're seeing it's equally as important to monitor for these attributes and be able to make certain actions based off of potential violations of ethical and trustworthiness notions. For example, a couple of elements or attributes that we would look for an AI system include accuracy of the system. It's very common to think about performance of AI models and software when we're designing these systems, but the design decisions here and the way that they affect the design of the overall pipeline is key. Similarly, we have a couple of other elements around explainability or transparency, as I had mentioned previously, as a core vector of AI ethics, security, privacy, accountability, and similar. The other interesting point that I want to bring out here, the differentiation of machine learning pipeline assets and data is critical. So here, typically in the security domain as well, machine learning could be viewed as, just another data point. So the same protections or attributes, documentation, and similar that you would apply to regular data points, including the same protections, would apply to machine learning. Is this correct? To a certain extent, yes. For example, we do have regulations such as GDPR and similar for data protection that can apply to AI systems. However, we are seeing that we need specific regulatory action and technical implementation in order to address unique needs of machine learning, or in other words, AI models. That includes very detailed processes and, again, mitigation mechanisms for the attributes that are mentioned on this slide. Now, I'm going to very briefly go through a subset of regulatory guidelines and laws for the explainable AI domain, just picking that apart, really. And again, recapping here, what we're really trying to figure out with the explainable AI domain is understanding what's going on inside an AI model. Why is it trying to make a certain decision? This domain is constantly evolving. We're not able to answer all of those questions right away, but some of the approaches that have been developed across academia and industry are now being used to be able to provide, to a certain extent, validation of AI models' outputs and understand better what's going on. So a couple of regulatory guidelines here. The National Institute of Standards and Technology has noted that AI systems should be able to deliver accompanying evidence for all their outputs, and these explanations should correctly reflect the system's processes. We see similar types of perspectives reflected in the European Commission's guidelines on ethics in AI, including noting that the requirement means that an explanation should be available on how AI systems influence and shape the decision-making process. Similarly, the Singapore Model Governance Framework notes that it's possible to use a combination of different tools to improve the explainability of an AI model's decision. Finally, as relevant to this audience, I did want to mention as well a guideline that is being introduced as part of India's Responsible AI for All Operationalizing Principles for Responsible AI approach document here, which is noting quite clearly that deep learning models have become increasingly opaque, leading to black box phenomenon. This can lead to a lack of trust by users, difficulty in auditing, and also inability to comply with specific sectoral regulations. So here the document is proposing that if the explanation is crucial to the system and accuracy requirements can be met, then recommending the use of explainable AI models. Now, with that being said, let's also start to look into a very brief analysis of the AI supply chain. And here I'm only going to get into approximate stakeholders, and then we'll be looking at a simplified pipeline of AI models and similar in a moment. So here, what are some approximate stakeholders if we consider the entire end-to-end pipelines of AI and the landscape? Some approximate roles and responsibilities might include model developers. These are the data scientists and the engineers who are debugging your model, trying to figure out how to get more performance and more value add out of the AI model when it comes to accuracy and similar types of metrics. They can be responsible for some sort of validation to a certain extent. Next, we have our business owners, and a lot of different, consumers of technology may fall under this category, who are really responsible for evaluating the fit of the model for the business use case and agreement of use, transferability related concerns, etc. In accordance with some of the EU Commission's guidelines and similar, we could also divide these into data controllers and data processors categories for, really establishing methods of processing data for the AI system, and then processing of the data itself, which might be distinct. Next, we also have some the stakeholders related to model risk evaluators, who we are very clearly, keeping separate from the model developers for this particular overview. And these model risk evaluators are really responsible for starting to check for those AI ethics related concerns like robustness and deployment readiness. Next, we've got the regulators or supervisory authorities, who are responsible for the reliability and impact assessment of the AI pipeline. Now, finally, maybe potentially one of the most important stakeholders in the supply chain are our users or consumers. For example, lay people who may not have access or more education related to the internals of AI systems. So what really are the transparency requirements there, and how do they affect our end customers is critical to think about. Now, that being said, let's get into the technological innovation section. Here, I wanted to cover a short subset of AI lifecycle implications for ethical AI and trustworthiness. This is where we're starting to see differentiated levels of AI system trustworthiness at training and inference phases, as well as at research and productization. And here, the research productization differentiation is really reflecting a lot of the work being driven in academia and then being adopted by industry. And as we're seeing, regulatory bodies then kind of taking the feedback from industry and then creating the regulations accordingly, thus causing a feedback loop, which is influencing the different stakeholders and organizations accordingly. Now, when we talk about lifecycle implications, first we're considering this from a pure software perspective. DevOps and production operations do come to mind as well. And what are the ways that we can measure for AI ethics, as well as start to establish and potentially have some actionable outputs coming out of the pipeline? Now, here I would like to recommend, based off of landscape overviews and similar, that security can be seen as a enabler for establishing and measuring trust, and therefore also to a certain extent the ethical nature of an AI system. So here I've got this picture at the bottom with essentially a core machine learning pipeline in light blue consists of data configuration, the machine learning model processing itself, the processed model that's outputted, the metric evaluation and debug done by our model developers, and then finally, although not in light blue here, still considered kind of an added part or extended part of the core pipeline, interfaces and user in the loop support. Now, some concerns related to ethical AI and trustworthiness, and by concerns I mean mitigation mechanisms that we place or embed within this pipeline, in addition to measurement mechanisms that we can think about. At the first data stage itself, we want to be able to monitor and audit data concerns. During the configuration phase, we want to be able to check for privacy-related concerns as well as potential data. Now, during the machine learning model processing, would be a great time to introduce the energy efficiency component and be able to understand and potentially guide the design of our machine learning models so that they have less of an impact to our environment by, for example, including metrics such as carbon intensity or similar. During the processing and optimization stage, we have measurement-related technologies proposed for model bias evaluation and explainable AI to understand the internals of the model. During evaluation, we have some thoughts around accuracy and robustness evaluation, where, again, we could use this as part of, the steps where developers are trying to figure out, do we pick this model or this one? Accuracy is a really great metric. We want the performance and, the value proposition for the business to be intact, but we also want to guarantee that the impact to our users, as well as the security, is intact as well. So robustness can be considered as a key metric that we introduce here. Finally, during the surfacing and actuating section, we want to make sure that the output bias and safety evaluation and validation related checks are put into place. You can see here that biases are really considered and measured throughout the pipeline, and security and transparency is that final bottom pillar. Now, on the note of user in the loop support, which is starting to emerge as a very, additive concern to AI ethics, this kind of feeds back into the monitoring and auditability component, where the user is able to influence the AI system with decisions they're making. And there's some requirements and expectations on these types of supports that are coming, again, from regulatory guidelines. Okay, so now we've kind of talked about this from the software perspective. I did want to introduce, again, very briefly, some of the kind of defenses, mitigations, measurements that we can start to introduce from, hardware and software levels. So here on this slide, I have a proposed Intel framework to build trustworthy AI systems that we are working on. This really starts from foundational platform security, where we are introducing secure platform solutions, including hardware foundations to establish trust anchors, provide features such as tamper resistance, bootstrap, and recovery. Next, we also want to consider trusted compute and isolated execution, including isolated executions for sensitive workloads and protecting data that is in use. Now, after that, we're starting to get higher, I'd say, in terms of, getting to the software levels and the application-related levels. We would want to be able to provide toolkits for model IP protection and secure deployment, where you're protecting data and you're providing confidentiality and integrity, and also being able to enable features such as differentiated privacy or for federated learning and similar types of use cases. Now, going further, let's start to address more of those trustworthiness elements directly. Data protection and privacy preservation. What we would want to put in place here is an AI machine learning protection framework for secure deployment and APIs for Intel OpenVINO related tools and scale to the ecosystem. Finally, we have AI ML trustworthiness extensions related to lifecycle support, explainability related features, inspectability with measurement and reporting tool sets, etc. So this framework that we've built out has a couple of existing technologies that are ready to use right away for customers and teams that are interested in leveraging Intel technology to help with foundational platform security from the hardware level all the way to getting started with these trustworthiness related concerns at the software level. With that,
Thank you, Ria, for a very insightful session on ethics in AI. We have a couple of questions from the audience. Can AI ethics be a roadblocker for AI progress?
Thank you so much for the question. And I would say definitely. AI ethics can be a blocker in terms of compliance-related concerns, as well as technologically can sometimes hinder the solution. As an example, the two ways that this can occur, firstly, again, the compliance angle where, you would have to keep in certain gates as part of the processes for checking your models. And secondly, some of these solutions targeted towards AI ethics can sometimes lead to some problems with the AI pipeline requiring improvement. So I would say these are the two primary domains to think about.
Okay. We have a couple of questions. The second one is, you talked about regulations being followed by a few countries in Europe and Singapore. Do we see a universal regulations being in place both at the global level and also sector-wise, because it becomes more relevant to have these regulations on sector-wise?
Right. I would say absolutely. We are starting to see, with the emergence of these local and sectoral types of regulations, also the emergence of global regulations that are coming out of this. And I think some standards are serving as essentially the global type of framework definitions for these. But what I've learned from some experienced colleagues who are participating in the standard space for AI, as well, is that, yes, it is all kind of attempting to unify at the end. Again, starting first with that definitional framework and then slowly progressing further to more complex and additive AI ethics technologies to your AI pipelines.
One from in fact, a developer. The question is, do we have a repository of some tools or resources available for AI developers?
Okay. This is a great question. And I think as part of this, the primary way of searching for these tools is really domain specific. For example, if I wanted to enhance the explainability of my model, depending on the task and the use case, I'd go about searching for the repositories. I think we're in great need of a single repository that is able to accumulate these different technologies and put them in one place. But I think, again, the best way to go about it as of now is if I'm, let's say, in the computer vision domain, I've got an object detection or classification model, searching for the explainability methods that support that particular domain is the way to go. The similar type of philosophy or mindset applies for fairness, secure machine learning, energy efficiency, etc. Very task specific.
And we have one last question to go. That is, trustworthiness and transparency pull in opposite directions. Will regulators be able to satisfy both without compromising robustness of ML processes?
I see. And yes, this is a very interesting contention from a technological perspective, but I see this question has also raised it from the policy perspective. And yes, I think in this particular case, since a lot of AI ethics related implications and trustworthiness implications as well are really kind of following the cycle of first technological innovation followed by upcoming regulations and policies, and again, like that feedback loop, I think that as we continue to find technical solutions for this, we will be then able to construct more robust policy from the policymaker's point of view. An example of this, in the last slide, I mentioned inspectable AI-related toolkits, where we are able to balance the robustness and overall security of end-to-end pipelines, but also enabling transparency beacons. And for more information here, please feel free to reach out to me. But I think to summarize, the technological solution will come first, and then the policymakers will be able to leverage that for some great regulations that are applying for this contention.
Okay, probably one last point. I wanted to share your views to the young engineers. I know you're one of the youngest in the space, and share your views to young engineers, aspiring young engineers who want to get into AI. What you would like to suggest to them?
Oh, absolutely. I think I would definitely suggest, of course, the never stop learning motto is awesome and definitely true. I think there's a lot of different concepts in AI that can sometimes be intuitive to grasp and other times a bit overwhelming. There's so many resources out there, even in the AI ethics domain, just so many tools and domains to look forward to. And I think really deciding on the, I'd say, backgrounds or the contexts that are interesting to us and then pursuing that forward is critical. For example, I've had an interest in neuroscience tied to artificial intelligence over the past few years, and what I've been able to do is pursue the fields and domains that best appeal to that particular approach. Now, neuroscience and AI ethics can be considered a bit of a stretch here, but any kind of application tying into human psychology was my personal interest. So I would definitely encourage any young engineers who are looking to rock on in the field of AI to find the context and use case that matters to them, and then go forward with that curiosity and interest.
Thank you. Thank you. It was really wonderful to have you for this session. And it was great insights. Any questions we will direct to you. Probably we will forward those questions in case